right, it looks like it's working. So, hello everybody. This is Jordan Anderson with Cloud Underground. I'm here today to do a quick speed run Underground Nexus setup on a Raspberry Pi. So, I have a Raspberry Pi here in a case that I designed and printed. It's a 3D printed case. It actually, I'll show you the internals real quick because it's kind of cool. We're using a PoE hat, so Power over Ethernet hat on this to make things a little easier. I also have a SSD on this case, you can see, which is plugged into the USB with a USB to SATA adapter, and the Raspberry Pi itself is covered in an aluminum case that's in here that's all cooled with a little Noctua fan, so you can see all that. So that's the setup I'm running with. Yeah, so if you're ready, your Pi is all set up and ready to go, then I guess we can start installing stuff, and I'll start this speed run off, and we'll see how fast I can do this thing. So yeah, if you're following along, feel free to try and race me or whatever, and let's get this thing started. So I'm gonna start our timer here. Okay, the first thing we need to do is flash our SSD here. So I am going to use Baleena Etcher for that. Raspberry Pi also made a very nice little utility that they have. If you want to use the Raspberry Pi.org or the Raspberry Pi Foundation's flash utility, please feel free to do though. You need to enable SSH though, so make sure you select that in your advanced options when you are setting that up. I already have the most recent Raspberry Pi OS downloaded, so I'm selecting that. I'm going to select our 512 gigabyte drive here. That's what's on this Raspberry Pi, and let's flash it. You will need to allow Windows command process to run. Windows will bark at you, so go ahead and click yes. I don't think you saw that on my screen, but and you can see we're flashing. Because it's an SSD, it goes pretty quick, so we're not going to have to wait very long for this. And done. Okay, so now I'm going to unplug the SSD and just plug it back in, because I am using Baleena Etcher, so I did not have that option to enable SSH the way you might if you were using the Raspberry Pi Foundation's flashing utility. So if you are using Baleena Etcher, what you do is you open up boot once you're back into your hard drive. You make a new text document, you title it SSH, and you delete the extension. Very important. It must be SSH with no extension. Windows will bark at you about this. Just say yes, that's fine, change it. So now we've got this SSH file in here. That enables SSH on this Pi. I'm also going to do a overclock on this. So in order to do that, we can open config.txt. I'm using Notepad++ to do this stuff, so these modifications. Okay, here's our overclocking bit. So we will delete that hash to uncomment this. We want it to actually run this code, or this setup inside the Raspberry Pi OS setup thing. Okay, so we're going to add over voltage equals 8. I'm going to do a pretty ambitious overclock on this Pi. We're going to try 2300 with a GPU freak of 500. This is from Tom's Hardware. They had used these in a Raspberry. Actually, they used a much larger overvoltage, but this is a really good Pi. I'm pretty sure that we can make it work with these settings. So, save, exit. We are overclocked. We are SSH'd. I don't know what that other file was. Don't worry about it. Hopefully it was nothing. Don't worry about it. Anyway, okay, we're gonna go ahead and plug our Pi in here. So I actually used a different cord because this one's so short to talk to my computer for the flashing. There we go. So we're all plugged in. Because I got PoE, all I got to do is plug this thing into my switch, and we are powered on and running. It's going to take the Pi a moment to actually get the file system set up and the OS set up enough for us to start doing things. So I'm going to kind of sit here and talk for a moment. While that's happening, I'm just going to watch the light on my switch and see when, basically, once the Ethernet light turns on and starts activating, that means that it's probably ready to go. Just so you know, I am using PuTTY to do the SSHing into our Pi, so I'm going to go ahead and open up that utility real quick. So here's what PuTTY looks like. The IP of this particular Pi is going to be the following. I know that because I actually already had set up this Pi's IP to be static in my router, so I don't have to, like, every time I plug it in, it's always going to be the same, regardless of whether or not it's a new OS or not. So I see my Ethernet light is off still waiting for the Pi to finish setting up. Hopefully that will happen pretty quickly. It is always possible that the Pi won't boot because I put too aggressive of an overclock on it, but I see the activity light going. We're going to go ahead and give it a shot. So, of course, it opened on my other monitor. Okay, so we just got this security alert, and that basically means that we're good to go because it's saying, Windows is saying, you have never talked to this device before, it could be a hacker, you better know what you're doing, basically. So, we do know what we're doing, and it's just a Raspberry Pi we're talking to, so we're all good to go. Default login, Pi. Default password is Raspberry if you're using Raspberry Pi OS. So, okay. The first thing that I'm going to do, because I want it to activate the next time we restart, is get the C group set up. So in order for Kubernetes to work, we need to add this little line right here, so group memory equals 1, so group enable equals memory, to the end of our cmd line.txt file in boot. So we're just going to copy that. We're going to go back to our SSH over here, get us into this. Go to the end of this line. I believe it'll say root wait at the end. Give it a space, and then we will add in the C group options. Okay. I am not working on my primary monitor, so if it looks weird that I'm constantly looking away, that's why. Anyway, so this is now done. Control O to save, Control X to quit nano. So now we've got the C groups enabled, which is critical for Kubernetes. Next thing we're going to do is sudo rasb config, and we are going to give this unique host name. All our Pis need to have unique host names for clustering and swarm reasons. So this is going to be test pi 1, and we're also going to set some localization options. I like to set the time zone, and it's a good idea to do land country. I'm not going to do that this time, but whatever. Okay, so we got our time zone set, and most importantly, we went to system options and changed our host name. So, and gave this a unique host name. Now when we reboot, that will also activate the C group stuff. So that's why I did that first. I'm going to watch for my Ethernet light to turn on over here, and then I'll know the Pi is booted again. And then once the Pi is booted, we're going to update it, and then we're going to install Docker. So we've got our Docker installations up here. And just so you know, this is a little bit ahead, but we're going to install Docker using by setting up a repository rather than using the convenient script or anything else. I think it's a little easier to update this way, so this is the way I'm going to do it in this particular video. Okay, I think our Pi's back. I probably talked longer than I should have. Raspberry. Oh, okay, that reminds me. The other thing that we're going to do real quick is change our password. So PASSWD, we'll do that. Current password, Raspberry. New password. We're going to make it easy. I still screwed it up. Oh, it doesn't like that. Fine, I'll choose a longer one. can't pull the distro tube 123 password apparently. So I'll use my normal one. Okay, so password is updated, and now we're ready to do our update, like I said. So sudo apt update. This shouldn't take too darn long. And then we do a sudo apt upgrade. Okay, this one's going to take a little bit longer, and we're going to have to say yes. So we'll do that. Okay. But we're going. We're moving. We're moving. And then once this is done, then we can set up Docker. And once Docker is installed, then it's just a hop and a skip to the Nexus. So we are doing good here. We should ensure that our overclock is working. So let's duplicate this session. And I should have, wrong monitor. Okay, so here it is. So pi, put in my new super secure password. Alrighty, and then we can, okay, our upgrade's done. Okay, so that'll be for later. Now we're gonna start getting our Docker going. I will say real quick, I know that we already have this stuff installed, so we're going to skip the first step of setting up the repository and go straight to the second, because this stuff's already on Raspberry Pi OS by default. So we're going to add the Docker official GPG key. Boom. Done and done. Then we're going to echo this command, which is adding that to our repository list, I believe. And once that is done, then we simply do a sudo apt get update followed by the install Docker commands. All right, and yeah, of course we do. Apparently didn't mind that I accidentally put a slash there. It looks like it's working fine, so that's good. Always annoying when you hit that backslash key. I'm kind of at an awkward angle. I should move this a little bit, make it a little less awkward for me. Okay, so, you know, obviously I've been talking a little bit and giving a little commentary, so this hasn't moved quite as fast as it probably could have. What is all that? So it returned an error. What happens if we do sudo docker info? Okay, so it can't connect to the daemon. I had this happen last time. Let's just do a sudo reboot and see what happens on this guy. And unfortunately, that of course killed both of these connections. But that's okay. I'm going to wait for the Pi to reboot and see if it works. I don't understand why we got this error. Code exited, auto restart. All right, well, we're just going to see if the reboot fixes it. It did last time. Looks like it should be ready to go. All right, it is ready to go. So let's see if Docker is working. Sudo docker info. Oh yeah, we're talking to our daemon now. Okay, so I think we're good to go now to install the Nexus. So we'll get off of Docker's website and we're going to go to github.com/underground-ops/underground-nexus. And then that's the website that talks about the underground Nexus. and we're going to use this Docker development pull for Raspberry Pi. However, we need to add sudo to the beginning because we're in Debian. And then the other thing that we're going to have to do is get rid of the port 22 mapping in this command because we are already using port 22 for this SSHing. So if we try and run this Docker command as is, we will get an error. So we will get rid of port 22 here. And now we should be ready to run this. So sudo and then the command without port 22. Unable to find locally. Pull in a bunch of images. And this should be a relatively quick pull, you know, depending on your internet speeds. I have relatively good internet here. Certainly better than we did have. If you've been following any of my LinkedIn posts, you might have seen that we actually got on Starlink at this location, and it's been really, really fantastic. Okay, the container is running. Let's just do a quick sudo docker ps, and boom, there it is. It is going. So now, to unleash the power of this container, we have to run this little docker exec command, which docker exec runs this script inside of the container. And because we are on Debian, we need sudo, and we don't natively have enough permissions with this user. We could probably elevate the permissions of this user so we didn't have to type sudo all of the time, but since we don't really want to be working in this SSH shell most of the time anyway, I think for security purposes it's better just to leave that alone. Run your commands with sudo in front, and then once this is done, you really won't be messing around in your SSH shell much. So this is going to take a while at this point. I think it took me about 15 and a half minutes to get to the point where I was running this script. So the Nexus is not hard to set up on a Raspberry Pi in particular. It's set up to be pretty quick. Actually, it's a little more difficult on a Raspberry Pi though than it is on a Windows machine, because you actually need the C group stuff and like sudo, and you have to get rid of the port 22. And there's a few extra little steps to make it work on Raspberry Pi. But yeah, it's still very simple, very easy, and man, this script runs a lot of stuff. It's a hefty guy. It takes a bit for this to run. This is the second time I've done this speed run because I accidentally messed up the audio on the first recording, but that's okay. So I'm doing this again, and it took me a little less time this time to get here than it did last time. But yep, working good. I also want to show you that indeed we are overclocked pretty crazy on this Pi. So we have our second terminal here that's actually inactive. I think we can activate it without messing anything up above. We'll see. Okay, we're good to go. So we can just htop this and just kind of ensure, yeah, check it out. Raspberry Pi is working pretty hard. We're unpacking images. We're doing stuff. We're going to press F10 to get out of htop, and then we're going to run a couple of commands to show you what our clocks are right now. So if we do vcgen cmd measure clock arm, that's the command. So if you run this command, vcgen cmd measure underscore clock space arm, it will tell you the frequency of your CPU, and you can see that we are currently running 2300. So no sweat for this Pi, honestly. I've overclocked this Pi further than that and had it be stable. So pretty intense. Like I got some good silicone on this particular one. Yeah, you can see for the most part it dropped clocks there a little bit, but probably just because was downloading and not unpacking files. Because you will see we are not at all thermal throttled on this. Let's check it out. So if we do vcgen cmd and then measure _temp, that will give us the temp of our CPU. And you can see we're just above 40. So 40C, we're doing good. We're doing really good. With that, and that's with a 2.3 gigahertz overclock on the Pi. So yeah, this single Pi case that I designed has beaten everything else that I've tested in terms of thermals. It's a really, really good design in terms of that. So yeah, hopefully we'll get those for sale soon if anybody is interested in checking those out. I'm not sure that I have a whole lot else to say at this point. I will say, I guess, in terms of fancy Pi cases, I ran across a really cool one you guys should check out if you get the chance, and it's the Cooley Pi case. So COOLIPI. Search that in Google and see if you can find it, because it's a pretty cool deal. It's like this giant extruded aluminum heat sink thing that sits on top of a Pi, which is essentially what this case is, with a plastic shroud around it that blows fan over that aluminum case. But the fins on the Cooley Pi are really impressive. I'm sure that thing is way overkill, but you know, so is our case. So anyway, yeah, this thing, it's going, and it's gonna keep going and keep going. I think I'm gonna pause this video at this point, and I will come back and update you when the script finishes. Hopefully it'll actually run the whole script this time. Last time it ran across an error, but we still ended up with most of this stuff at the end, so it was okay. But yeah, hopefully this time it's just gonna go and work. Yeah, sometimes it doesn't, and you know, again, it took me, what, 15 minutes to get this all set up. So in the end, if you have an error, something doesn't set up correctly, and you need to reflash and just like start totally from scratch, that it's not a big deal. There are actually plenty of ways to just prune all of the stuff out of Docker to that old image and stuff. If it doesn't work, you just make sure the images are stopped, and then you can prune everything and delete all the old containers and old images, and then pull it again, and it you know, hopefully will work the second time. But it's pretty easy to restart Docker or restart your machine from the very beginning if you have a problem. So yeah, I think that's, again, all I'm going to say for the moment. I'm going to pause this, and I will update you with the time once the script is done. So I will be back. Okay, I'm back now. I did forget to actually put my mic back on, which is why there's no audio, and I am now recording over the original video track. So sorry about that. Note to future self, you have to have a mic on you to actually get audio. Anyway, you can see that the script finished right before 35 minutes. So we started running the script at about, I don't know, 15 seconds after 15 minutes. That means that the script took just under 20 minutes to run fully. You know, your results will vary, obviously, as I said earlier, depending on download speed and the speed of your device, but still pretty impressive. You can see that I'm now, you know, going to the web top, so you can see that that's working. Our Guacamole client with that Mate desktop is working, so that's pretty neat. I think I'm basically going to call it there. I went over a few more things originally, but since the recording got messed up, I'm not going to worry about that. So thanks for watching this video. I hope it explained how to basically install the Nexus on a Raspberry Pi and get everything going, and there's lots more content out there that will explain how to access these web tops and like use Pi-hole like I'm checking out now, etc. So I'll link some of those videos in the description, and Yeah, thanks again. Talk to you later.